Hello, dear students. In the previous lecture of P block elements, we are discussing the compounds of oxygen family. Today, we are discussing our last compound of this family, that is oxo acids of sulfur. Yesterday, I have told you that there is a lot of oxo acids possible in case of the sulfur, out of which H2SO3 sulfurous acid, H2SO4 sulfuric acid, H2S2O8 peroxide disulfuric acid, H2S2O7, that is called oleum, pyrosulfuric acid. These four are the most important dear particles. Okay, you know that this is particularly sulfurous acid form when we put the sulfur dioxide into water. This will form the sulfurous acid. But out of these, all the most important is H2SO4, your sulfuric acid. So about this particular oxo acid, we have to discuss its preparation, its properties, and its uses particularly. So let's start it first. So H2SO4 is made by a process named as a contact process. First, okay, it is a basically three-step process. The first step is production of SO2. Production of SO2 by burning sulfur or sulfide. Second, conversion of sulfur dioxide to sulfur trioxide. Third step is particularly absorption of SO3 in H2SO4 to give H2S2O7, that is your oleum. This is the third step. Okay, now let's discuss the second step a little bit in deliberate first. Before discussing the whole process, contact process, let's discuss this secondary step first, because this is the main step that in which we are converting sulfur dioxide into sulfur trioxide. This is also a chemical property we shown in the case of the sulfur dioxide when we discussed the sulfur dioxide compound. At that time also we discussed the same thing, that sulfur behave as a reducing agent. So sulfur dioxide in presence of oxygen easily get converted into sulfur trioxide, but the catalyst needed is the vanadium oxides. So if you balance this equation, so you will see two molecules of SO2 combines with one molecule of SO2 and result in the two molecules of sulfur trioxides. So from this you can clearly see that the gaseous volume is decreasing. So that's why by Le Chatelier principle, increased pressure is the favorable condition for reaction if you want to move in forward direction. Next thing, when we are doing the oxidation of sulfur dioxide to form the sulfur trioxides, a large amount of energy is released particularly. Okay, mean to say this reaction is particularly exothermic. So that thing proves that low temperature is favorable for this reaction. So if you want to go convert sulfur dioxide to sulfur trioxide, two conditions are the basic, that you must have increased pressure and low temperature. But still we carry out this process at 72 Kelvin and 2 bar pressure. The pressure is quite good, but 72 Kelvin, the temperature is not much lower. Why we didn't take the temperature lesser? Because at the low temperature, the reaction speed becomes slow. However, the low temperature is favorable for the conversion of, or you can say, product concentration, but the reaction rate will become slow. That's why we are doing that at a 72 Kelvin and 2 bar. This is the perfect condition particularly. So there is a question asked you in text question that what are the favorable conditions for the production of the sulfuric acid. So the increased pressure and low temperature are both those two conditions which are needed for the production of the sulfuric acid. Now I am drawing you a diagram, particularly a flow diagram for contact process. Okay, in which this is first particularly chamber. You will see here are the slots over which sulfur is putted. Air get inhaled from here. Here it is sulfur. So this is burning chamber particularly, or you can say sulfur burner. We burn sulfide or sulfur. It will result in the production of SO2 plus O2. Okay, then we will pass this particularly to a dust precipitator. Here you will see a dust precipitator particularly. This is known as dust precipitator. If there are any dust remaining, we will let it out particularly from here. Okay, now we will pass this sulfur dioxide and mixture of oxygen particularly into the next chamber, which is known as water sprayer or cooling tower particularly. In this we are passing sulfur dioxide plus O2. Okay, from above water in, or you can say water spray from here. From here water out. Here are some columns which for the efficient use of the water spray. Okay, from here you will comes out sulfur dioxide plus oxygen in the moist form. But in moist form, sulfur dioxide start behaving as reducing particularly. So that's why we will pass it to another drying tower. Another tower which is known as drying tower particularly. From here waste acids comes out. From here sulfur dioxide and oxygen mixture is coming there, and from above we are spraying the concentrated H2SO4 there. Why we are spraying? Because after that, because sulfuric acid is a quite good dehydrating agent. That's why this is known as drying tower. I mean to say moisture which get involved due to presence of this water spray over here. That's why we are spraying concentrated, so that the moist SO2 get converted again into dry SO2 plus oxygen mixture. Okay, then this dry oxide SO2, and I am drawing this particular diagram further here. This dry SO2 plus O2 mixture then is passed to arsenic purifier. Here you will get another chamber because there are some impurities present in sulfur as well as in sulfide ore, particularly arsenic. So that's why this chamber is known as arsenic purifier. Arsenic purifier, which contains hydrated ferric oxide, which is good absorption power for the arsenic. Okay, so arsenic gets separated over here. Now you will get a preheater particularly here. This is preheater, mean to say we are raising temperature for the necessary condition, that is particularly 72 Kelvin temperature is we are providing. Okay. Now after passing from this preheater, the gas is passed particularly to catalytic converter. Catalytic converter have beds particularly of over which a catalyst we will found, which catalyst? Vanadium oxide particularly. Okay, it will shown in the diagram particularly. So from here you will see that SO2 plus O2 we are giving, but the result output will be SO3 there. Okay, after that we will pass this SO3 sulfur trioxides into a chamber where we are spraying concentrated H2SO4. Concentrated H2SO4 we are spraying over here over sulfur trioxide. It also have quartz bed. So after here sulfur trioxides H2SO4 get absorbed on the sulfur trioxides and it will give you H2S2O7, that is your oleum. When you mix this H2S2O7, that you are saying that you will say that why we are preparing H2SO4 but we are showing for the H2S2O7, because when you put H2S2O7 into water, it will result in the production of 2 molecules of H2SO4. You know, in the whole process you are saying that concentrated H2SO4 is also used, one for the drying, one for the absorption at the sulfur trioxides to produce oleum. But in the whole process the amount of concentrated H2SO4 used is actually half than the production. The produced amount is double that we are using. So that's how we are producing concentrated sulfuric acids particularly here by contact process. Okay, now so today we have discussed about the preparation. So preparation is a little bit longer in case of the contact process. So properties and uses we will discuss tomorrow dear regarding the sulfuric acid. So today first thing you will do is read up to page number 190 in CRT. Second, make your notes in fair notebook. Third thing is solve blueprint question and answer in rough note. Thank you.